Welcome to Big Three's whiteboarding example on section 4.1, 6.4.1, I think. Yes, it's the statics perspective. In this video, we're going to be looking at this truss system. Here's the system as it looks. Here's the system broken down into the individual forces. Alright, so we're given a 2-bar system. It's anchored at these points. We have a force of 1,000 newtons, whether that's a weight or just a force being applied to it, going straight down perpendicular to the x-axis. We have a length of 10 meters for this in this example, and we've named our pin joists, labeled them 1, 2, and 3. Now, since this system has to be in static equilibrium, the sum of all the forces at all the points has to equal 0. So, right here, we've broken this up into N12 and N13 is what we're calling our compression forces. Calling our compression forces N12 and N13. We're calling our reaction force for, let's write that says joint 2 and joint 3. Reaction force for joint 2 and Rx is depicted here. For Y is depicted here. For X is depicted here. For Y is depicted here for joint 3. Alright, now as you can see here, I've written out all the equations written in the book showing the sum of the forces for each point. Joint 1, x, y, joint 2, x, y, joint 3, x, y, has to be equal to 0. Alright? Now, we can solve this system equations and actually get values we're looking for. Okay, if we simplify the first equation up here, negative n12 cosine of theta plus n13 cosine of theta equals 0. Simplify that, you can see n13 cosine of theta will equal n12 cosine of theta, so they're equal to each other, same force. Alright, and substituting, since you know n12 and n13 are equal, we can substitute into equation 6.9b and find our force. What we do is we can put our 1,000 newtons in there for our total force, and we can find N12 and N13 because they're equal to each other. We could just maybe say, just pick one, N12. We know N13 is going to be equal to it. That would then equal negative 707 newtons of compression in each truss right here. So we'll have, we're just labeling it negative because it's going together, negative 707 newtons of compression there inside the beam, and negative 707 newtons of compression here inside that beam. They're equal. Alright, now if we substitute the value for our force of 707 newtons for N12 and N13 into the remaining equations, we're going to get a result like this. We can substitute these equations, and we can figure out that R2x is equal to R2y is equal to R3x, and they all end up equaling 500 newtons. So let's write that right down here. First, let's depict that. Alright. We're going to have R2x at a force of 500 newtons. We're going to have R2y at a force of 500 newtons. We're going to have R3y at a force of 500 newtons. We're going to have R3x at a force of negative 500 newtons, because we define motion to the right as positive, obviously. Okay, so I'm going to work this out here for you, if you don't mind. We were solving for N12 equals N13. That's going to be force over 2 times the sine of our angle. So now we have N12 equal to N13 equal to F over 2 times the sine of theta. We get that because what we do is we add the N12 and N13 together. We can just cross one of those out. And we're going to have 2 times the sine of theta that divides F, and we end up getting negative 707 newtons for reaction forces. That's where we got those reaction forces from that I stated before. Okay, now if we're going to substitute that value for either N12 or N13 in any of these equations, we're going to get, like I already stated, R of 2x is equal to R2y is equal to R3y, which is going to be equal to 500 newtons when we do that substitution in there. So in the end, we're going to have 500 newtons going this way, 500 newtons going this way, 500 newtons going this way for this one, and we're going to have 500 newtons going this way. This will be negative 500 newtons in that direction, and we'll have positive 500 newtons in that direction, and when you add all these forces together, they will equal 0. So it will be static. That means the bridge, or whatever structure you have, should stay in one place, as long as your materials can withstand those forces. Now that's where knowing how much force your materials can withstand will come into play. Now you know it's going to have to withstand negative 707 newtons of compression, and also an X component of negative 500 newtons. Okay, so that's going to pretty much conclude it. I hope you enjoyed this video a lot.